Today we will take a look at game objects, which are probably one of the most important topics in Esenthel game engine. Right now we have some models in this world: the castle, the mage, the enemy, some trees, but all of them are just static models. They don't have any behavior to them, you can't do anything with them. And what game objects do is they allow to assign some behavior to certain objects in our world. Game objects are defined by object classes. Esenthel engine comes with some object classes already defined, for example the terrain class, which handles some objects which are static throughout the game and never change. There is also a grass object class, which is optimized to handle a lot of simple objects scattered throughout the map. To see what objects have what classes, we can go to the object section of this editor and click on anything. For example, let's click on the grass, and we see that it's currently in the terrain class. Tree is also terrain. The mage is also terrain. By default, everything we import here is a terrain class. We can't access it through code, and we can't do anything with it. But let's say we like to make our grass have the grass object class. There are several ways we could assign a class to an object. One of them is through the world editor. We just click on an object, and here select grass object class. We see the blue tick box appear here, which means that its default class is overridden, and so its default class is terrain, and we override it with grass class. But given that we have several hundred grass objects here, it's not a very good idea to change them one at a time. So we can go to the object editor, to our grass object, and in the params menu here, assign the class to grass. We'll look at other parameters a bit later. For now, we can return to the world and see that our grass objects are now all of class grass. To better understand how all this works and to see how to create our custom object classes, let's try to add some behavior, for example, to our castle. Right now it's just a static model, but let's say we wanted to have some health, and every time we click on it, its health will decrease by some amount. First thing we need to do is to create an object class for our castle. I have already created it, but to make one yourself, just right-click, New Object Class, and give it some name. If we open it, we see the Object Class Editor. Here we have some options for our object. The const parameter defines if the object is included into the save file or not. You should enable it if the object will never change throughout the game, but our castle will change, so we'll leave it empty. The path mesh parameter controls if we include our object into the path mesh or not, and we don't want anyone to move through the castle, so we set the create option, which includes the object into the path mesh. Draw as has several options. We can draw as a mesh or some lights or particles. We'll look at lights and particles in later videos. For now, we'll just leave it as a mesh. And here is a window for our custom parameters. We can add them with this button. They can have a lot of different types. They can have a name and a value. For now, I'll leave only one parameter, which will be an integer health with the default value of 100. Now, as we did with grass, we can open our castle model and go to the parameters and assign its class to object castle. And we see that our custom parameter appeared here. We can override any default parameters if we'd like, but for now I'll leave it like this. The next thing we need to do is to write some code to set the behavior of our castle class. For this, in the tower defense namespace, I have created castle class, which inherits from game static. The Esenthel engine comes with several predefined object classes, which can be used as a base for our custom classes. For example, game static is a class for solid objects which position will never change, so it suits well for our purpose. There are also kinematic class for objects which will move by setting their positions manually, the item class, the door class, the destructible character, animatable, and so on. You can find them all in the Titan Engine, Game, and Objects folder. And there is also the very base object, which is a base class for creating custom objects. We could inherit from this and write our object from scratch, but given that this is a beginner tutorial, I won't do this right now, but I'll leave a link to a tutorial which goes through the process of creating an object from scratch in the description. So we've decided to use the game static object because our castle will never move, and if we go back to its definition, we see that there are already some methods and members defined, but we still need to do some work. Currently, this object does nothing. The main two functions we'll need to override is the create function and the update function. The create function takes in an object, which is a set of parameters that we set in our object class right here. It will allow us to pass some custom parameters into the objects we create. And the update function will update our object with some custom behavior, and it will return either true or false. It will return true if the object wants to continue to exist and continue to update, and if we return false, this object will be deleted from the world and be no longer accessible. You can also see that there are some other functions we can override, and we'll look at some of them later. For now, I've overwritten create and update function and some draw functions, which I'll explain a bit later. I have also added the receive damage function and some getters for its destroyed state and its health. Now let's look at the implementation. In the create function, first thing we do is call the base class create function. This will initialize our object with its basic parameters like position, matrix, and we pass our object into it. Now, since we have some custom parameters, in this case health, we need to extract them from this set of parameters into our code. For this, we check if we can find the parameter with the name health inside our object and get the pointer to it. If we can find this parameter, then we put it into the health member variable, interpreting it as integer, since our parameter is an integer. If we look at other options, you can see that all available parameter types are here. So if you have a vector parameter, a text parameter, and so on, you can interpret them as needed. And now this health member variable will get the value that we set in this value field. Next, we'll look at the update function. Here, we at first check if the health of the castle is more or less than 0, and if it's less or equal to 0, we set the destroyed to true. And then we have this piece of code. First, it checks if the castle is destroyed, and if it is destroyed, then it does nothing, since we don't want any logic to be possible with the destroyed castle. And then we check if the mouse button is pressed. Here I check for the left mouse button. And now, since we want to change the health of the castle only when we click on the castle, we need to cast a ray to where our mouse pointer is pointing. For this, we create two vectors, one for the position of the ray and one for the direction. Now, with the function screen to pos dir, we convert the position of the mouse to position and direction. This is a handy function which can be used whenever you need to cast a ray to the mouse pointer, and it will take the position and convert it into 3D coordinates in our world. Now we create the physHeat object, which will store the information on our ray heat results. And now we check if our ray from position we set here into the direction we are pointing hits anything. We write all the information about this heat into our physHeat object, and then we check if the object we hit is in fact our castle, and if it is, we damage this castle, for example, by 10 health points. Now, why do we multiply our direction with the D view range? This is a view range, so how far we render our world. If we look here, we see that the direction is normalized, so it will be of length 1, and we'd like our ray to not be of length 1, but go until the end of the visible range. Here, to check if the object we hit is indeed our castle, we check the obj member of the physHeat object. If we look inside physHeat, we see that we can get a lot of information from it, and right now we just check if its object member points to our castle object. And then, after all this is done, we return true. So why don't we return false when we are destroyed? I don't want the castle to disappear the moment it's destroyed. I want it to stay in the world, but just with 0 health. And returning false will delete the object, which I don't want for now. And now let's look into the draw functions. If we look at the base object class, we can see a lot of draw functions for various rendering purposes, and all of them have descriptions, but the main of them is the draw prepare. Here we add all the meshes we need to draw to a list for drawing, and then use return statement like this to call other drawing functions. For example, if we'd like to, in addition to our mesh, draw its shadows and its outline, we return draw shadow and draw outline. Here, I am overriding it for the purpose of displaying the health of our castle, which will be drawn in text. First, in the draw prepare function, we draw the mesh. The mesh is a member of the static object class. We use the arrow operator here since the mesh is of type mesh pointer. If we use the dot, we get the mesh pointer object, and we like to access the mesh itself, not the pointer to it. So we use the arrow operator, and here are all the members of the mesh. We use drawn and draw it at the matrix. Matrix, once again, is defined in the static class, and it just returns the normalized matrix of our object. After this, we return two things. We return rm shadow, which we'll call draw shadow, and rm blend, since we'll draw our text in the blend mode. We add them together since these are flags and return them. Now in the draw shadow, we simply draw the shadow of the mesh at the same matrix, and in the draw blend, we call D. D is the display class, and it has a lot of functions related to drawing as well. For example, we can draw text on the screen. The first thing we need to pass is the position of the text. We convert position in the world to the screen position. We get the position of the castle plus some vector to move it up a bit. So we don't want to draw the text exactly at the position of our castle, but a bit above it. And then convert this position to the screen coordinates, and draw the text which can display health and the amount of health we have. This S is a constant empty string, and it is a good practice to add it anywhere you want to display some text. For example, if you want to display just some variable and the function only accepts car pointer, you need to add S to have some character first, and then this will be properly converted into text. And below it we'll draw some more text, which will say if our castle is destroyed. If it is, it's say yes, otherwise no. And here are just some helper functions for receiving damage and getting health and destroyed. Now we've completed the behavior of our castle, but we still need to map our castle object class to our castle class. For this, in the main code file, we create game object map templated on the castle class, and let's call it castle container. You should create it outside any function, since it will need to persist throughout the game. Now in our init function, we also add physics. Since we use the physics ray function, we have already some physical interactions, so we need to create physics for them to be handled properly. And before creating a new world and loading it, we set object type in the castle container to object castle, which is our object class we created earlier. Now everything is properly mapped, and our castle object will update together with the world and have some behavior. So let's launch the game and look at it. So we already see some text. Health is 100. Is destroyed? No. And if we just click on the screen, nothing happens. But if we click on the castle, the health gets decreased by 10. And if we get to 0, it's destroyed? Yes. So our castle is behaving correctly, and this is the purpose of game objects. This is the same way we'll implement our player, our enemies, and other things. One last thing I'd like to show is why are we creating parameters here? Why just not assign health here, like say 100? It seems to be the same thing. But what's cool about these object classes is if we go into the world, we can override these parameters the same way we can override the const, path mesh, and other parameters, and have different object of the same class have different parameters, and even add some more parameters to them. For example, let's add another castle. Let's leave this one at 100 and set this one to 500. We see that we've overridden it since the blue checkbox appeared. And now, when we launch the game, we see two castles. One is with 100 health, and one is with 500 health. And they both behave in the same way since they are both of the same class, but they have different starting parameters.